All right, guys. So I know as I move around, the lighting adjusts on the screen. So just bear with me as I move. I will let it adjust so you can see. So I'm gonna exit out of here. We're gonna move on to the next slide. And if you have Nearpod up, I'm gonna ask you to read this. You're probably not gonna be able to read it off of my screen, but you do have it on your own Nearpod screen. So this is the I can statement, what we're gonna be able to do by the end of our lesson today. And Samira, would you please read this for us?
I can explain patterns in products and quotients. When numbers are multiplied, divided by powers of 10.
Excellent. So we're going to find patterns, something that happen over and over again in products and quotients. Those are the answers to multiplication and division problems. When numbers are multiplied or divided by powers of 10, and we know that powers of 10 happen all throughout our place value charts. So we are going to be working with that today. Great job, Samira. Thank you. Okay, so I do not want you to solve this first problem. I'm actually going to solve the first two on the screen, like on our Zoom screen. So make sure that you are able to see Zoom at this point in time. If you're having to go back and forth between Zoom and Nearpod, make sure you are on Zoom. So I'm going to solve the first two, and then you're going to get chances to solve some as well. So we're going to start with this first problem, and it is 1 36/100 times, which is multiplication symbol, and then we don't know, there's a blank there, and we ended up with 136. So we can see that we have the same digits. We have a 1, a 3, and a 6 in both of these, and our decimal has simply moved. So we know we have to be multiplying by a power of 10, and now we just need to solve to figure out which power of 10 it is. So the way that most people have enjoyed solving these types of problems is using our place value chart. That seems to be the way that makes the most sense to everybody. So that's what I'm going to start with. So I'm going to start with our first number, which is 1 36/100, and I'm going to write it on the screen. Again, once I step away, if you're having a hard time seeing it while I'm up here drawing, once I step away, it should become a little clearer, and I'll move it up here as well to help you see. So I'm drawing my place value chart. I know this is my ones place. I need to redo that because that was way too big. Sorry, guys. So 1 36/100. This is my ones, my tenths, and my hundredths. And I'm going to come over here and do tens and hundreds. Okay, so I, at this point, have this first number in my place value chart. Notice that my decimal is right here in this number, and then you don't see a decimal for 136, but we know the decimal is invisible, and then it's sitting right here behind the 6 because the decimal is always to the right of the ones place. So I'm also going to draw this number, our product, in the place value chart, making sure I line up each digit with the correct place value. So I know this 6 is in the ones place, so I'm going to go ahead and put my 6 there and put my decimal and fill in the rest of my digits. Any questions so far about what I've done? Okay, I've got some hands raised, so I'm going to go ahead and answer those questions. Oh, Jamari put his hand down. Samira and Genesis, I think your hands were from earlier, right? Samira, do you have a question? Okay, go ahead, Samira.
How do you know that the dot is near the 6?
Okay, so it's not a dot. What's it called?
Quotation mark.
No, it's our decimal. You know that. Decimal. We know that our decimal is behind the 6 because the 6 is in the ones place. Whenever we draw a ones place, we always have our decimal there. So our decimal is always behind the ones place. Never changes.
Okay.
Good question. And I don't see any other hands at this point in time. So I'm going to keep going. So now to figure out how many times we have to multiply 1 and 3600ths to get 136, I simply just look at my place value chart, just like you have before. And I notice that the 1 that's right here is up here. So I had to move up 1 place value, I had to move up 2 place values. And we know each time we go up in place value, we are multiplying by 10. So we multiply by 10 twice. So we know 10 times 10 equals what? Can y'all put that in the chat for me? What does 10 times 10 equal? Thanks, Fumi and Mackenzie. Oh my goodness, y'all are doing excellent in participating on the chat. Thank you so much. Yes, 10 times 10 equals 100. So we actually multiplied 1 and 3600ths times 100 to get 136 because we moved it up 2 place values. So this is 1 bunny hop and this is another bunny hop up to a place value. Or for those of you who are used to being in the classroom with me, we could also call that a kangaroo jump. We did one big jump from the ones place to the hundreds place. And another way you can look at it is the value of the 1 in this place is worth 1. The value of the 1 in this place is worth 100. We had to do 1 times 100 to get that. All right, questions now. Okay, I'm not seeing any questions. So I'm gonna go ahead. Oh, Asia, yes ma'am.
I'm still a little confused.
Thank you so much for saying that. I appreciate you letting me know. So we're gonna solve another problem and I wanna see if maybe doing a couple of these helps to clear things up. If not, we're gonna work through it together as well. So by the end of this lesson, I'm not gonna let you leave until you're feeling better about it, okay? Thank you for letting me know that.
Okay.
Awesome. All right, I'm gonna close this one. Whoops, I'm gonna get off. You do not need to draw anything for this one. You do not need to submit anything on here. Thank you to Colin. He went ahead and just wrote the answer in because I gave it to you. You can do that if you would like. Otherwise, I'm just gonna move us on to the next slide. So I know for some of you, it might take a second for your Nearpod to catch up, and that is A-okay. I'm gonna solve one more with you, and then after this one, it's going to be your turn. So again, make sure that you can see my screen up here and you can watch me solve. All right. So this problem, we have 768 and we need to divide by something to get 76 and 8/10. Again, we have all the same digits, so we know we're just multiplying or dividing by powers of 10. We're just changing where our decimal is in this number. So we are going to do the exact same thing and take our first number and put it in a place value chart. Again, we know that our decimal is always right behind that ones place. So it's right behind that 8. So this is our ones place, tens, hundreds, and again, I apologize, my handwriting is not the best on the TV screen. And we also have the tenths, and I'm gonna leave it right there. And now I'm gonna go ahead and write my quotient, which is the answer to a division problem, also in the place value chart below here. Notice my decimals between the 6 and the 8. So I need to make sure my decimal and my digits line up correctly with this. So notice that they shifted but my decimal does not change. And I still have my digits lining up with the correct place value. This 6 is in the ones. So 6 is in the ones here. 7 is in the tens. 7 is in the tens. So make sure whenever you start to do this, you're lining up your digits in the correct place values, because it will mess you up if you do not. All right, so now I have to figure out what did I divide by to get 76 and 8/10. Well, we can see that this digit 7 moved back one place. What do we know happens when we move back one place value? Can you all put that in the chat, please? What happens when we bring it back, bring it back, bring it back, one place value? What happens, guys? Thanks, Cullen. Thanks, guys, as you're putting in answers. Make sure you're understanding the question. The question is, what happens when a digit goes back one place value? So you can see the 7 was in the hundreds, and now it's in the tens, just like Genesis said. Great job. Thanks, Josiah. Guys, make sure if I ask you to respond in the chat that you do. Even if you're not sure, put your best guess. All right, friends, I'm still not getting a ton of answers, but I'm going to use the ones that I've gotten so far. So a lot of people have said some different things, all of which are correct. So I heard that the digit moves backwards. It absolutely does. I've heard that the number gets smaller, which it does, because it went from 700 to 70 because the 7's in the tens place. I've heard that we move the 7 to the tens place, and we are dividing. Yes, absolutely, we're dividing. So whenever we're going backwards, we are dividing. And we are dividing by 10 because we went back one place value. Remember, whenever we move across one place value, it's always 10. So going backwards, it's dividing by 10. So we had to divide this whole number by 10 to get 76 and 8/10. You can look at each digit, and each digit was moved backwards one place. You can also think about it as 700, because the 7's in the hundreds place, and the 7 is in the tens place, so it's 70, and we had to divide 700 by 10 to get 70. So you can break it down even further. All right. Do I have questions so far? Some questions might come up as you're attempting to solve on your own without me doing it. Yes, Samira. No? Okay. All right, guys. So I'm going to go ahead and close this one out. And I'm going to skip the next problem because I don't really want y'all to solve that one. So you should end up with, on your Nearpod, 3 6500ths divided by blank equals 365 thousandths. So this is one that I want you to solve. So I'm going to give you a couple of minutes to go into your Nearpod and to draw your place value chart, show your work, and then make sure your answer is nice and clear. If you want to write your answer right here below the question mark, you can absolutely do that. Again, just give it your best. And if any questions arise while you are trying to solve, I will be right here to answer them. But I'm gonna close it out. I'm gonna look at some people's work. So I have a friend that kind of did what we talked about, but actually used a different strategy. And I'm not sure if they knew it or not. So this person right here actually used the decimal slide. So I know that they took the number 24 and 74 hundredths, and then they just did the decimal slide. They didn't actually really use their place value chart the way that we have, which is perfectly fine. You can see with her work, she knew the decimal was originally right here, and she had to slide it back 2 times to make it match 2,474. So we know the decimal is always behind the ones place. So the decimal ended up here, and she knew that times 10 and times 10 and 10 times 10 would get us 100. So we would be multiplying this number by 100. So this is another strategy that you could use if you understand that whenever you move the decimal, each time you move it is going by a place value of 10. You just have to be careful with knowing which direction to move your decimal. That's one way. And then this person right here did a great job of labeling their place value chart. They wrote both of their numbers in the place value chart correctly. You can't really see their decimal, but it is right there. I see it. And then they recognized that they moved the 2 from the tens to the thousands place. The 2 went from tens to the thousands. That's going up 2 place values. So that's times 10, which is 100. So you had to multiply by 100. And sorry to be going so fast. Lastly, oh, this one. This is another favorite mistake of mine right here. So my favorite mistake, and somebody else made this in the last class, again, a great teaching moment. So this person, it looks like they mistook our comma right here for a decimal, is what it's looking like. So we have to make sure that we recognize the difference between a comma and a decimal, because that can mess us up. So we got to be extra careful, and we really need to use that place value chart that we've talked about, so we make sure we can see as the place values are changing. So great job for giving us another learning moment. And we are going to go ahead and stop right there. Thank you, all of you who submitted your work and were participating. I'm very proud of you. And today is not the only day we're going to work on this. We're also going to do this tomorrow. So if it's still not feeling super clear, hopefully it feels a little bit better than it did at the beginning. If it doesn't, stay on Zoom with me and we can talk some more. But I'm going to let you go. I hope you have an awesome rest of your afternoon. You have no work from me today. You already did the work.
Bye.
Have an awesome day. Bye, guys.
Thank you.
Bye.
Do you think I did good today?